Hey guys, welcome to another chemistry video, and today we're going to be talking a bit about naming organic compounds. Now, there are a lot of organic compounds. If you study biology, you will know that there are indeed many of them, and many of them are incredibly complex. However, at this level of chemistry, around the AS and A2 level, we only meet relatively simple compounds, such as just basic alcohols and carboxylic acids. But it may seem as if naming them is still daunting, because there is still such a great variety. And it only seems difficult because it might seem as if we don't have a system of naming all these compounds, especially when different functional groups and different multiple bonds and whatnot are thrown in. But as it turns out, the International Union of Pure and Applied Chemistry have usefully created a single system which incorporates all of these things. And from this, you can deduce the name of a compound from its structure, and also the structure of a compound from its name. So it's extremely useful. And to demonstrate how we can apply this system to naming a compound, I'm just going to take the example of this compound, which I won't name now for obvious reasons. But anyway, using this example, I'm going to demonstrate to you a kind of step-by-step systemology or algorithm which I use to name compounds. And it's not necessarily the same ordering that you have to take, but it's just a system which I have found works for me. So here goes. First off, we would identify the parent chain. And by parent chain, I mean the longest chain of carbon atoms that you can make in the compound, without any kind of branching or splitting of any kind. And in here it happens to be 7, so we call it hept. That is the first step, just call it hept, because it's 7. In this case, of course, knowing a bit of Latin won't hurt, but you should be familiar with all the prefixes from about 1 to 8, I suppose, would be. So meth, eth, prop, bute, pent, hex, hept, oct. I don't think you'd really need to go any higher than that. But anyway, the parent chain. Now if you realize, we could actually build a second parent chain with the same number of carbon atoms just by choosing a kind of different branch to go through. Now in this case, it doesn't actually make a difference, because either way we're left with hept. And either way, the geometry of the molecule actually remains unchanged. It's just the way that we draw these diagrams which make it look as if there is a difference, when actually there's not really a difference. But anyway, that's the first step. Simple, right? Just identify the number of these carbon molecules in the longest chain. So anyway, on to step 2. Identify the functional groups, if there are any. And in our example here, we see that we have an OH functional group at the end. And that's how we can tell that it's an alcohol. So now, we have hept and we have ol, but there's still some stuff in between, so without further ado, let's move on to step 3. Number the carbons with locants. Now, by locants, I just mean giving them numbers from one side of the chain to the other. So 1, 2, 3, 4, 5, 6, 7 in this case. Now here I've presented it as going from left to right, but actually in this case it should go from right to left. But why? Simply because we're trying to choose the numbering which gives the functional group the lowest numbered carbon to attach to. So now, instead of being attached to carbon 7, it's attached to carbon 1. We're trying to give it the lowest number, remember. So now we have hept, and we have 1-ol. 1-ol because the OH group is attached to the first carbon. If it was attached to the second carbon, it would be 2-ol, and so on. Now on to step 4, now that we've numbered them. Identify any multiple bonds. And by multiple bonds, I mean bonds greater than a double bond. And there don't seem to be any, so let's move on to double bonds. Ah, there is a double bond. That's nice. Following our numbering system, we could number the bonds as well, actually, instead of just the carbons. In the same direction, though. And from this, we can see that this double bond rests on the third bond. So that's why we call it 3-ene. we add this "ene" bit because it does it denotes a double bond, which is why molecules with double bonds we can sometimes call alkenes. But anyway, here we go. On to the next step. Identify any branches. Here we can see that there are two branches, and both of them have only one carbon involved, so we call them methyl groups. And they exist on carbons 5 and 6 respectively, so we can call this 5,6-dimethyl hept 3-ene-1-ol. And that's the full name of the compound. Yeah, that's it. We're actually done. In just 6 easy steps, we've been able to name this compound, which may initially look complex, but the naming system is actually very simple. Now, let us repeat this procedure just to get the feel of it with another example. How would we go about naming this? Now, I'm going to give you a chance to kind of think about what the first step would be if you can remember. Okay, here goes. Step 1. Identify the parent chain. And here it involves 8 carbons. So the prefix is oct. Now, what's the next step, if you can try to remember? That's right, identify the functional groups. And as it turns out, there aren't any here, so we can skip this step. Now, previously, in the first example, after identifying the functional group, we were able to create a numbering system for this chain. And we were able to choose which direction it went in accordance with this functional group. But now that we don't have a functional group, we have no way of knowing whether it should go from right to left or left to right. So we leave the numbering alone for now. Usually the functional group takes precedence, but it's not here, so we can kind of ignore it. Now let's move on to multiple bonds. Once again, there aren't any multiple bonds, so let's move on. Double bonds. Ah, there is a double bond. Right there. So now we tailor our numbering system around the double bond. In effect, we're tailoring our numbering system around the first thing that pops up, with the order being functional groups, then multiple bonds, then double bonds. So now we can kind of number it now, so it becomes oct2-ene, because it's the second bond, because we're going from left to right, because the double bond is closer to the left. So yeah, that's most of the way. We've just got one more step to go, if you can remember what that is. Yeah, identifying any branches. Now here, we've got two different kinds of branches, one with 2 carbons and one with 1 carbon, an ethyl group and a methyl group. So we couldn't name it diethyl or dimethyl, so we just call it 2-ethyl, 4-methyl, oct2-ene, because the ethyl group is on the 3rd carbon, the methyl group is on the 4th carbon, and then the oct2-ene we've already established before. See, it is not very difficult. If you can kind of practice and remember the methodology and get the hang of it. So let's give an overview of what we do. First, we identify the parent chain, then identify any functional groups, then identify multiple bonds and double bonds, and through that process, we number the carbons with locants as soon as we've discovered the functional group. If it's not there, then the multiple bonds, and then the double bonds. And that's the order we go in. Then after that, we simply identify the branches. The branches always come last. But that's just my way of doing things. If you have a better way that suits you, then feel free. But that's just the way I can kind of logically order this. But yeah, now that we've done that, let's try naming this compound. Oof. Yeah, it's not very difficult after those examples that we've just looked at. It's but2-ene, but because it's 4 carbons, 2-ene because it's an alkene, because it has a double bond, and this double bond rests on the 2nd bond. But yeah, at this point, hopefully you thirst for some more challenging compounds. Anyway, thank you for watching. The next video that I'm going to make is going to be about naming more compounds. And when I say naming more compounds, I mean we're still using this kind of system, this methodology, except there are more homologous series and types of organic compounds to remember, such as alkynes, aldehydes, carboxylic acids, halogenoalkanes, ketones, and all that jazz. So, thanks for watching. I sincerely do hope you've enjoyed this, and we'll see you next time.